All right, so we're going to begin 1.2, which is piecewise defined functions. Our objective today is to be able to graph it as well as step functions. Now, my first essential question is, how do you graph a piecewise defined function? Well, what is a piecewise defined function? Basically, it's a function that we literally cut in pieces based on domain rules. Okay, now let me explain that as we do this problem. So here's a piecewise function, and there's a few things that you got to notice. The first one is that there's two sides to each. Actually, the first one is that there's three functions. 1, 2, and 3 functions. Okay, so we're gonna graph 3 pieces of each and one of those functions into my graph. The second thing that I want you to notice is that there's 2 parts into the piecewise function. The first one shows you the equation. The second part, after the comma, shows you the restriction, so the domain rule. All right. Now, within the domain rule, notice that there are some less than or greater than, and there are some less than or equal to, greater than, equal to. When we graph those 2 restrictions or rules, some of them are going to have an open circle. Some of them are going to have a closed circle. Now, which ones are which? The ones that are going to have an open circle, those are going to be greater than or less than. The ones that are going to give you a closed circle, those are going to be greater than or equal to, less than or equal to. Okay. All right. Now, before we get started, there are 2 skills that we need to have, or that we need to remember before we do this. And those are that there are 2 equations here. There's a linear equation, which is in the format of y equals mx plus b, which means that this is your y-intercept and this is your slope. The second one is your absolute value, and that is usually in the format of y equals a x minus h plus k. Okay, if you can't write that down, remember that you already have it on your notes, so you don't have to write it down. Just remember that for an absolute value function, in order to graph it, you need to find your HK form, and then you need to use your slope to find the rest of the points. Anyways, now that we remember that, we can go ahead and start graphing our piecewise function. Now, what I want you to do is basically separate each equation individually. So the first one that we're going to graph is number 1. Now, number 1 is y equals 2x plus 5. So let's go ahead and graph that function. This is a linear function, which means that 5 is your y-intercept. So I'm going to go to my graph and graph a point, or draw a point in my y-axis at 5, which is right there. So that is my y-intercept. Then I'm going to use my slope to find a bunch of points so I can draw an accurate picture. So I'm going to go, since there's no fraction, I'm going to put a 1 under it, which means my slope is up 2 over 1. So that's going to be up 2 over 1. And then I'm just going to keep finding more points. If you want to do it on the left, just do that in reverse. So instead of going up 2 over 1, you go down to 1 to the left. So down 2 over 1, down 2 over 1, down 2 over 1, and so on and so on. I think those are enough points. So I'm just going to go ahead and graph my function. Okay, now that is my equation y equals 2x plus 5. However, I do have a domain rule. So if you remember, my domain rule for this function is -6 is less than or equal to x, which is less than or equal to -3. When you see a restriction that looks like that, or a domain rule that looks like that, that means there is a left boundary and there is a right boundary. So I only want to see the piece of my graph from -6 to -3. Well, how do we do that? Go ahead and find those 2 boundaries. Well, where's the left boundary? The left boundary is at -6, which is right there. The right boundary is at -3, which is right there. All right, and remember, we're looking at left to right. We are looking at the X values of the Y-axis. All right, cool. Well, once you find the boundaries, I want you to erase everything that is not within the boundary, which is this and this. All right. Once you have that little piece, all you got to do is determine if it's going to be an open or closed circle. Both of them are equal to, which means that on the left, you have a closed circle, and on the right, you have a closed circle as well. Both are closed. And that is how you graph a piecewise function. Now, we're not done. We only graph one piece of the function. Let's go ahead and graph the two other pieces. So I'm going to graph the second piece, which is y equals 2 times the absolute value of x minus 7. So this is an absolute value, which means that we need to find our h and k. Now, notice that inside of the absolute value, there's no h, which means that your h is 0, and your k value is -7. Well, once you find that, just go ahead and plot it. 0, -7 is right there. The next thing we're going to do is we're going to use our slope, which is your a value. In this case is 2 or 2/1 to find the rest of the points. And because we want to V, we want to make sure that we do it to the right and then to the left. So we're going to go up 2/1. And then I'm just going to keep finding more points. Up 2/1, up 2/1, up 2/1. And then also to the left, up 2/1 to the left, up 2/1 to the left, up 2/1 to the left, up 2/1, and up 2/1. Cool. All right. Well, I'm going to draw my graph. Well, that's my absolute value function. However, I have a domain rule, which again, it's a restriction. My restriction is -2 is less than x, which is less than 1. Okay, well, again, I have two numbers, which means I have a left boundary and I have a right boundary. Let's go ahead and find those two boundaries. My first boundary is at -2, which is right there. My right boundary is at 1, which is right there. So anything that is not within that boundary, let's grab our eraser and just erase it. So that's gone. That's gone. And let's just draw our open or closed circle. In this case, you can see that there's no equal sign, which means this is going to be an open circle for both. So at -2, I'm going to have an open circle. And at 1, I'm going to have an open circle. And I'm just going to erase the inside of it. Cool. We're almost done. We got one more graph. And the last one is number 3, which is y equals -x minus 4. This is also a linear function, which means that this is your y-intercept and this is your slope. There's no number in front of the x, so I'm just going to put a 1. So my slope is -1. All right, so let's go ahead and graph it. My y-intercept is at -4, so I'm going to put a dot at -4. My slope is -1, which means I'm going to go down. And because it's not a fraction, I'm just going to put a 1 under it. So now my slope is going to be down 1/1. So down 1/1, down 1/1, down 1/1. And I'm just going to find a bunch of little points. Once I have enough, I'm just going to go ahead and graph my function. Cool. We're almost done. We got to graph the restriction, and the restriction says that this graph has to be in between 1 is less than or equal to x, which is less than or equal to 3. So I also have a left and right boundary. My left boundary is 1, my right boundary is 3. Well, let's find those boundaries. My left boundary is at 1, which is right here. My right boundary is at 3, which is right here. So anything that is not within that boundary, just go ahead and erase it. Cool. And now let's just go for open or closed circle. We see that they are both equal to, which means that they're going to be closed circle. So I'm going to have a closed circle on the left and on the right. Now notice that there's already a circle at 1 and it's open. But because I'm going to draw a closed circle, it's pretty much like filling in the hole. So instead of keeping the open circle, I'm just going to fill in the hole because now it's a closed circle. On the right side at 3, at the right boundary, there's also a closed circle. So I'm just going to draw a closed circle right there. And that is my piecewise defined function.